So I just saw this on Twitter, and then I went through the article just for like my own understanding because I got pretty curious about it. And this was a significant vulnerability that this person, Eva, reported and that they ultimately like discovered. And it was a very, very major thing. It affected, basically, it allowed remote code execution on some very popular applications, a couple, namely Cursor AI, like the code editor, as well as Notion Calendar, and several others. Basically, every app that is using ToDesktop, which is some software that helps you build and create an installer for Electron-based applications. And Electron, for people who are unfamiliar, is basically a way to use web tools to create desktop applications. So like JavaScript, basically, and then NPM packages and, CSS, things like that. I wasn't planning on making a video about this, but I thought that some of the things that I find interesting about this, I think this article is very, very good, but a beginner reading this might not fully understand everything that's going on here. If you end up finding this video helpful, definitely let me know, because these types of videos are honestly pretty easy for me to make, a lot easier than my LeetCode videos. But anyways, let's start from the beginning. And Eva, by the way, is like an anonymous penetration tester. I'm not super familiar with them, but on their blog, you can find out a bit more about them. I'll read through the article for you guys and then try to expand on each of the points. This started when I was looking into Cursor, an AI text editor. Also, I used Lulu by Objective-C on my laptop, so when I downloaded the Cursor installer, I got this pop-up. So they said, install Cursor, it's connecting to download.todesktop.com. So when they say they use this software, that is basically, looks like it's based on Mac OS. I'm not super familiar with this, but it helps you detect malware and block outgoing connections. So you can see that it was trying to connect to a remote server, right? A different location. So that's kind of why the pop-up came up. And then of course, Eva had a question. Now, what the hell is ToDesktop? I thought I was downloading Cursor. Well, looking at their website, they seem to be an Electron app bundler service alongside providing a SDK for Electron apps. So it appears the installer I downloaded is actually managed by ToDesktop, not Cursor. And so ToDesktop, I'm not super familiar with it, but it looks like it is a Y Combinator-backed company. Makes sense, go fast, break things, and sometimes break your customers' applications or, end up causing them to have remote code execution vulnerabilities. But anyways, I'm not going to, attack them because they ended up fixing the issue pretty quickly as soon as they were notified about it. But yeah, so just to briefly explain, this is my browser. You can see, and it is Chrome. Electron apps use the Chromium engine. So basically, anytime you have an Electron app, the most popular one that you're probably familiar with, I think, is VS Code. Cursor is a fork of VS Code, thus it also uses Electron. I think Slack is also Electron-based. And so that kind of allows you to develop a desktop application with web tools. I used Electron back in college. It's been a long time since I used it. It results in you having a pretty chunky application, but I think the developer experience is why mainly people end up using it. And so ToDesktop is, again, I'm not familiar with it, but I guess it makes it a lot easier for Electron apps to, build the application and then ship the installers to people. And so that was kind of the root of the issue. The issue came from ToDesktop themselves, and we're going to get into why. So after they learned about ToDesktop, this made me curious, and I made an account on ToDesktop to look into it. And when I clicked the GitHub login button, I saw my calling, Firebase. I think what they're saying is when you go to log in, and then let's say I click login with GitHub. And by the way, my website also uses Firebase. And the reason you could tell is if you, very briefly, you could see the Firebase URL and then it redirected to GitHub. I think clicking login with Google just makes it a lot more obvious. You can see that this just proves that they're using Firebase on the back end for authentication, and probably more than just that. Basic Firebase Recon. Realizing the app used Firestore, Firebase's NoSQL database that is often used in front end, I quickly opened my dev tools and began doing basic recon on Firebase. I realized that the site has source maps, which made searching for all the Firestore paths used in the app even easier. It's still easy without source maps usually. So when they say basic recon, they really mean it. This is not like some hacker advanced stuff. Anybody can do this. Let me show you. If you open up DevTools, I don't know if they still have source maps available. I guess we'll find out. But just opening up DevTools, going to the sources over here, and it looks like they don't have source maps anymore. I'm just kind of scanning through all these. Yeah, so the way I can kind of tell is that these files do not look like the original source files that were used to create this front end. So just kind of clicking through it, you can see that this JavaScript is not really human readable. It was probably minified and bundled up. That's kind of a process of JavaScript applications. Many of you probably already know this. I'm just mentioning it for people who don't. And so it looks like they don't have source maps enabled anymore, but just to show you, generally source maps are for development purposes. Usually when you ship code, you don't have source maps enabled. So I'm not sure why this site had source maps enabled, because by default, they're typically disabled. I mean, for example, let me show you. Going on NeetCode.io, I'm running this locally right now. And if I open up DevTools and I go to my sources here, you can see that you can see all the source files, right? You can see like the directory that I have. And if I like click through some of these pages, you can see the landing page, and you can see some code like over here on the right side. And you can see I'm also using a Firebase. But when I open up the website in production, like the live site, NeetCode.io, you can then look at the source files and you can see, well, they're not human readable anymore. These are the bundled files. And yeah, this is not like the original source code. So that's what source mapping is. And so basically they were able to just read through the code, and then they found an insecure collection, temporary applications, which seemed to give a name list of some applications. And it looks like ToDesktop clarified that that collection didn't have any sensitive data. And other than that, it seemed like everything else was secure. And then as they kind of learned about a ToDesktop, it looked like that this is kind of just like a cloud console where nothing, like the main logic doesn't really happen here. This is just for kind of managing the deployments. And the bulk of the logic happens in ToDesktop's NPM package, their node package, which is JavaScript based, ToDesktop CLI. So they installed the CLI and looked into it. The CLI manages deployments, source code uploads, and much more. The website just seems to be a shell to create applications, view deployments, etc. So I think I might have misspoken earlier, so sorry about that. It looks like the website is mainly just a wrapper, like the GUI, the UI, but it has limited functionality compared to the CLI tool. So they started investigating the CLI tool. I was once again lucky that the CLI also had source maps. That does make a little more sense, because when you have NPM packages, in many cases, the source maps are enabled, because then as you're kind of going through code, and let me kind of show you an example. You can see here in my editor, I'm using some imports from Angular. And if I click through into these, you can see like the definition code. So this is like the package, the NPM package, and this is the original source code of that package. It's human readable, and that's intended because in some ways it sort of serves as documentation. So it's not a bad thing to have like source maps enabled, I believe, for NPM packages. I could be wrong. If somebody wants to correct me, definitely let me know, but this is my understanding of it. And so as they looked through the source code of the CLI tool, looking in there, I found an arbitrary S3 upload vulnerability via a Firebase cloud function called getSignedURL, but I didn't really have an S3 key file path to upload to that would do something interesting, so I kept looking. I don't fully understand this because of my understanding of Firebase, and I've used it quite a lot. Within the CLI tool, I don't believe the actual definition of the getSignedURL code would have been in there, but maybe that function was being invoked within the NPM package. That's like the client code. So it was kind of making a request to the backend endpoint. And it looked like somehow they'd identified that there was a vulnerability with that. If they had an S3 key, they would have been able to upload any sort of file to S3 using that. And I'm assuming that they intended to have files being uploaded to S3. Again, I don't know exactly how the CLI tool works, but that's my understanding, or that's like my guess rather. Now, this is where things get pretty interesting. Hijacking the deployment pipeline via a post-install script. I wanted to get on the machine where the application gets built, and the easiest way to do this would be a post-install script in package JSON. So I did that with a simple reverse shell payload. this worked. Navigating around the container, I figured out where the actual code building application lives and found this. It looks like they found a file that had production credentials, but it was encrypted. And then they say, oh, fuck, this usually means something bad. I found the code for, they later found the code for decrypting the file. And I guess they don't go into details on that, but it seems like they kind of know what they're doing. I assume that they worked their magic. They found the code to decrypt it. And this is what I got after decrypting it myself. They obviously took out like the credentials, but these are production credentials. And they realized that was the case, that they had all the secrets here. Looking around in the container more, and I'm going to expand on what they're saying here, but basically it sounds like they had some kind of a persistent connection to the container that belonged to a ToDesktop, like one of their servers. And within their server, they had the container running that was intended to build user applications, because I think that's what their product is about. And generally, you shouldn't be able to have a persistent connection with them. And it looks like via like the CLI that they were kind of doing some investigation within that container. And then they found a hard-coded Firebase admin key, which was fully scoped. So I probably don't have to tell you why that's bad. I'm going to quickly just finish the rest of this up, and then I'm going to draw things out a little bit just to make things more clear. Post-exploitation, I quickly realized that with the credentials I have, I could deploy an auto update to any app of my liking, having clients receive it immediately when they restart the app. So very bad. It sounds like the product, like ToDesktop's product, I'm assuming it asks their users like, hey, for your application, do you want us to be able to push updates to it automatically? And I'm assuming that some people check yes, or maybe that's like the default or something. And by doing that, that kind of opens the door for vulnerabilities like this. If somebody has access to their server, then they can push the updates themselves. And that's exactly what they did. They tested it out. And I don't know exactly the details here, but they used their own credentials to deploy an update to their own app, and it worked. So basically what that means is remote code execution. You can deploy an update to an app, and your update could be any arbitrary code that you want, and thus anybody who has your software installed can automatically have updates pushed to them without their consent, I guess, or just the fact that they've downloaded the app would let them do that. Maybe there is some like permission on when you're installing, if you want to like allow updates or not. But either way, if you're installing an update, you expect it to be secure. You don't expect it to have malicious code, but that would not be the case if a hacker can just push arbitrary code. They could basically have code that's going through your file system or doing something that it shouldn't be doing, and then it's sending that data to a different server. So that's obviously why this is bad. Now, in terms of the impact, they mentioned that they would be able to push auto updates to all applications using ToDesktop. What got me a little bit confused here is that how could they do it to all applications when it sounded like they needed some credentials to do it to their own app? But maybe they implemented their application such that it needed some credentials to do that. But in terms of like what the fix was, we'll cover the fix towards the end as well. The fix had to do with credentials. Basically, for an app to receive updates, there would need to be certain credentials involved with that. But some of the notable apps, of course, ClickUp, Cursor, Linear, Notion Calendar, and I don't know any other applications that are using ToDesktop. They mentioned to not harass these companies because it's not their fault, and it really isn't. Obviously, they didn't know about such a vulnerability. How could you know that? And they mentioned, if anything, it's ToDesktop's fault, and kind of true, because there were a lot of things that had to go wrong for a vulnerability like this to exist. And it really, in my opinion, I don't want to like crap on anybody, but it does seem kind of negligent. Like, how could that have happened? And by their estimate, hundreds of millions of people could have been affected by something like this. Very, very bad. I honestly am grateful for people like Eva that investigate things like this and then report them. And it sounds like they were compensated. They immediately contacted ToDesktop. ToDesktop fixed the issue immediately. They were nice and they compensated Eva for the efforts. However much they were compensated, though, probably wasn't enough for the amount of benefit that they created for everybody else. The build container now has a privileged sidecar that does all of the signing, uploading, and everything else instead of the main container with the user code having that logic. So again, I'll cover that in just a second, but that was really what opened the door for this. The fact that you could take user code, send it to ToDesktop's container, and by that, it opened the door for creating a persistent connection with their container. Here's kind of my rough understanding of this, and I'm not like a security expert, nor am I an expert on kind of ToDesktop software and what exactly was going on in this case, but I'm just trying to understand it and maybe try to share my thoughts of it with you. So my understanding is that you have a ToDesktop, which basically manages the building and creating like the installer. So if you have your own application using a ToDesktop CLI tool or some other kind of way, you're done coding your application. It's Electron based again, so that's like a JavaScript based application. And then you send your application code, you push it to ToDesktop servers, and ToDesktop will say, okay, they have a container to do this because they know that the code that you're sending is potentially untrusted, right? Like LeetCode does things similarly. They will take user code and run it in a safe environment. My website does the same thing. If you send me code, I'm not running it on my own server. That would be very dangerous to do that. So they spin up a container. I'm assuming it's a Docker container or something like that. And so then this user code is in that container. That container is what is building your application and possibly doing other things with it. But this is, again, a JavaScript-based application. Within the package JSON, you can do something called a post install, which is basically run some command after npm install has been run. And I assume when the application is being built here, obviously it's going to install all the necessary packages. And then after that, the post install is going to run. And this is where I think things get into like networking and a little bit like out of my area of expertise. But from reading a little bit about this online, it sounds like what they did is pretty standard. They ran some code here that basically said, okay, from here, I'm going to open up a persistent connection now from this container back to the machine. So in this case, it was Eva's machine. They now had a persistent connection with one of ToDesktop's server instances. Now, even in that case, what could possibly go wrong? I mean, what kind of crazy stuff could be going on within that container? Well, it sounds like if you had an application, you're pushing it to ToDesktop server, you're doing that to distribute it to other users. And so if that's the case, within here, there had to be some credentials for maybe ToDesktop to then, after the application is done being built, to then push this somewhere else, maybe to other ToDesktop's servers or maybe to other users as well. And that's another step of where things went wrong. Because then Eva, obviously, after opening the connection, they looked around in there. They were able to get all the credentials, which is not something that should happen. And then they were able to push arbitrary updates not only to their own application, so users who have installed their own application, but to anybody who is using a ToDesktop application, an application built and distributed by ToDesktop. Again, that's kind of my rough understanding with it. I think I'm probably mostly correct. There might be some details I'm missing. If anybody wants to correct me or add a little color in the comments, please feel free to do so. One thing I kind of wonder is, why is all of this going on in the first place? Why would ToDesktop be able to push those updates? Well, part of the reason is to make the developer experience better. If you're just building an application, you don't want to worry about the distribution, the building, the installing, and things like that. So in some sense, people tried to take a shortcut, people tried to go fast, and then mistakes were made, and it sounds like they were pretty severe. Thankfully, they were caught, and it doesn't sound like anything crazy happened, but let's take a look at what ToDesktop had to say about all of this and the fixes that they implemented. It looks like ToDesktop just put out their press release on this just today, vulnerability report, and it looks like it was actually all fixed and handled on October 2nd, so we're just hearing about it now. It looks like nobody was impacted. The resolution time was 26 hours, so they acted pretty quickly. You do have to give them props for that. But again, this was pretty serious in terms of like the issue that could have, like how things could have gone wrong. And I'll skim through this. On October 2nd, security researcher Eva reported that she was able to gain access to ToDesktop's Firebase service admin account. We reviewed logs and inspected app bundles. No malicious usage was detected. There was no malicious builds or releases of applications from the ToDesktop platform. We promptly patched the vulnerability and rotated all keys. So rotating all keys is obviously good. So if Eva saw anything that she shouldn't have, well, now those credentials were meaningless, but rotating keys doesn't fix the vulnerability itself. They mentioned that they patched it, but they go into detail in just a second. In addition to patching the vulnerability, we engaged a third-party cybersecurity company to conduct an independent audit of our platform and pipeline. Again, it sounds like they're doing the best that they could. And here they have the timeline. So these are the steps that they actually took. Immediate fixes, rotated keys, again, patched the vulnerability by removing the Firebase service account token and implemented a restricted access solution, granting only the minimal permissions necessary for builds. That does make sense. So that sounds like within that container, you shouldn't have any permissions to do anything other than building. So now even if Eva was able to get a persistent connection to that container, well, one, the token, the Firebase token would not have been there. And again, maybe now that they wouldn't have permissions to go through all those files or to unencrypt any of the files, maybe they don't have that permission, or maybe they don't have permission to even open up a persistent connection in the first place. I'm not 100% clear on that. And it looks like they also enhanced alerts for suspicious usage of sensitive access tokens. So if somebody did get access to the tokens, they would know. And this was one of the interesting things to me. All customers must now use a security key web authentication token to release app updates, ensuring only authorized releases. This key-based authentication is managed separately from our main systems to prevent unauthorized access, even if other parts of our infrastructure were compromised. So it sounds like now, again, even if Eva was able to gain access and even if they had the credentials, that they would not be able to push an update to, for example, Cursor or Notion without the specific key that should, in theory, only belong to Cursor or Notion respectively. So again, that's a pretty reasonable thing to do. It sounds like it should have been there in the first place, but you can't blame people. Maybe I would have made the same mistake. But if anything, I think we're just realizing how difficult security is. You can really never make sure everything is perfect unless you actively penetration test. It's kind of reminds me of the discussion that we had with the DoorDash principal engineer, how you don't really know how well a microservice system is going to handle scaling and traffic and stuff until you actually test it and see what's going to go wrong. A few other things that kind of seem like they probably should have already been there. So implemented access control permissions for build and release processes, allowing account admins to assign specific permissions to team members and restrict sensitive actions to prevent unauthorized additions to teams. Inviting new users now requires authentication with a security key, ensuring only authorized admins can expand access. Sensitive actions, such as updating secrets or inviting new users, now trigger notification emails to the account owner. Most of those seem pretty trivial. And on the infrastructure and tooling side, they're just kind of expanding on something they mentioned earlier. We've applied the principle of least privilege to our ephemeral build containers, meaning each process has the minimal access needed to function. We've also open sourced 2 tools we built to help achieve this: Key Vault Gatekeeper and Firestore POLP. And they introduced an option for customers to self-host updates and downloads. The source code is freely available in open source with setup instructions accessible. This allows customers to manage their own self-hosted update and download infrastructure if they choose. So it sounds like they did all they could. I'm not here to pass judgment or anything like that. I was mainly just interested in sort of the technical details of this and just looking to learn. And I definitely learned something. I found this interesting. I hope you guys did as well. Let me know if you want to see more of these types of videos. Once again, really, really big props to Eva. I highly recommend you guys follow her on Twitter, and I'll put a link below for sure. That said, I know a lot of you guys are leak code monkeys, so I don't know how much she wants a bunch of random people following her. But anyways, I think she's a very, very smart and valuable person, obviously an ethical person as well. So can't really go wrong following somebody like that.